If the ground moved up and down a couple of centimetres, that'd be a problem, right? Well, it depends on your time frame. If it moved that much over the period of a year, you probably wouldn't even notice it. But if it happened within a couple of seconds, you certainly would know about it, and that's what we see in earthquakes. We don't use seismometers to monitor that long-term movement of the Earth. We use GPS satellites for that. To monitor the quick motion of the ground, we use velocity sensors or acceleration sensors. By factoring in time, we can make instruments smaller. So instead of measuring millimeters, we use velocity sensors to measure millimeters per second. It's not difficult to transform an earthquake recording from velocity to acceleration or displacement, but to do it in real time is a little bit more tricky, but we have managed to do that in a recent update to our seismographs. We measure the ground motion in 3 axes, east, west, north, south, and up, down, and then we find the peak acceleration, whatever vector that's happening on, and we can display that on the screen. The instrument can be set to activate an alarm when it exceeds a particular velocity or acceleration, depending on what sensor you've got connected, which can also be used for controlling systems to maintain safety during an earthquake, such as stopping an elevator at the next floor, shutting down a train line, or perhaps closing a gas main. So it's not just about how far the Earth moves, but how quickly that happens.